Present value of an annuity. I'm gonna change some stuff. It's gonna make things complicated. Okay. Who knows what an annuity is? Have you heard that term? What is it? What do you think it is?
I don't know what it is. I've only heard it. It's just because of the commercial.
Okay. Anybody else? What they're marketing in their commercial is, you pay them a certain amount of money now, they're gonna pay you a fixed amount of income over a set period of time. So a 25-year annuity, you'll pay them, I don't know, $100,000 now, they'll pay you $2,000 a month, whatever that number is. And the annuity is a level amount of payments that you get for a fixed period of time. That's it. Some of you actually have that in your life. Who has a car loan here? What do you pay?
I think it's $330 a month.
$330 a month for 7 years, maybe. I don't know, or 4 years, whatever the period is. There was a mortgage here. I know you guys are too young to have a mortgage. You're not. You're a geezer like me. Not as geezer. I am geezer than you are. Mortgage is the same thing. You pay a fixed amount of payments for a set period of time. All of those are annuities. You buy a Powerball ticket, you get the jackpot. Yeah, they give you two options. Either you get a lump sum now, or you get that money in 30 equal installments. That's an annuity. The only difference is the first payment is right now. That's called an annuity too. But we're never gonna deal with them, so know what it is, but that's about it. So let's go to that Powerball jackpot stuff. You got a ticket that has $1 billion, all right? They offer you $500 million. Let's assume there are no taxes, which is a big assumption. They offer you $1 billion now, or $500 million now, or you can get your money in 30 equal installments. So, and I'm going to assume you get the first payment 1 year from now, just to make things easy. Your payments, to make it easy, let's say the jackpot was 300, so that I can divide by 330 easily. So you're gonna get 10 million every year for 30 years, and suppose you believe that you could invest the lump sum that you get at 5% a year. Their lump sum offer is 150 million. Do you take it? That's the question. To figure that out, I need to figure out the present value of those 30 payments. If the present value of the installments are higher than the lump sum, except for other reasons, we tend to be impatient. We prefer the money right now. But if you're taking the money right now, you're going to know what you're missing. So we need to calculate present value of installments. The way the lottery works, You get 10 million now, and you will get 10 million a year for another 29 years. Okay? So let's make T 29. So I'm going to calculate the present value of next 29 payments, and I'll add 10 million to it because it's right now. How do we do it? Turns out, present value of an annuity that's equal to periodic payment divided by the interest rate times 1 minus 1 over. It's an ugly formula, right? You can call that, it's not a problem. We don't have to. That's the beauty of it. Excel actually has a function for that. It's called PV, surprise, surprise, for present value. R, T, and C. I'm going to add a twist to this for general purposes, not for annuity purposes. Also assume that there is a balloon payment $B at the end. So you get the last payment plus the balloon payment at the end of the annuity period. So PVA is then again, no problem coding in Excel, but turns out in Excel this is equal to that's it, done. So if I set up some sort of little template that I have those inputs, given those inputs, it's gonna spit out the present value. Let's go ahead and do it. Let's see, period rate, number of periods. Periodic payments. I'm gonna insert another one. Let's put in balloon payment. For now, I'm gonna add a 0. Period rate. What did we say your rate was? Did we say it? 5%, okay. So you believe you could earn 5% a year for the next 29 years, because you're going to get $10 million now. 10. zero balloon payments. Let's calculate present value. When you have a function that has multiple inputs and you're not exactly sure what order, well, you don't have to worry about it. Click on this little FX button. Find your function. In this case, I've already used it, but I could have done something like this. All, and click somewhere and type PV. It got you there. Hit OK. And it tells you exactly what those rates are. Rates, 5. Number of periods, periodic payments. This is normally optional. If you leave it blank, it's going to assume it's 0. But in this case, I'm going to do it explicitly. It actually gives a negative number. That's because this function has been written probably by an accountant that thinks of debits and credits. That's why I'm going to put a negative in front. The last argument is optional. If you leave it blank, it calculates present value of what we call an ordinary annuity, which means the first payment is made at the end of the first period. The other one is called the annuity due. First payment is made right now. But I'm not going to worry about it. It's okay. There's a reason it did nothing here, because it's a negative number. Let's change the format to accounting. In accounting, a negative number has a parentheses around it. But I don't like negative present values unless it meant to be negative. So I put a negative in front. So the value of the next 29 payments is 151, plus you're going to get a 10 million now. So at 5%, present value of getting the installments is $161 million. If they're offering you 150, you're leaving money on the table, right? Now, let's use this to do something actually useful. What did you say your payments were?
330.
330. And what do you think your interest rate is?
It's 6.7.
6.78. How many payments you have left, roughly?
About 8.
About 8?
Yeah.
This is 6.78 annually. I'm going to actually divide that by 12. We'll get to that. We'll actually make it general. So every month you're actually paying 0.565. You have 8 payments left. And 330. That means if you were to retire the loan right now, you would have to pay them 25.74 and some change. Let's call it the payout term.